Good morning to everyone. So myself, Team Kumar, Assistant Professor, Konkanadu College of Engineering Technology. Today, I am going to deliver a lecture on successive approximation type analog to digital conversion. So under the linear integrated circuits. So this is one of the analog to digital conversion technique. So here we are going to use a special type of resistor called successive approximation resistor. So it is called successive approximation type analog to digital converter. So this register gives us an efficient code searching technique called binary search technique. So here in this technique, we are using the binary search technique. The important blocks of the or important parts of the analog to digital converters are comparator, successive approximation resistor, SAR, digital to analog converter. So this is the block diagram of successive approximation type ADC. So here, comparator is available. So it is the operation amplifier. So we are giving the input Vi to the negative terminal of the amplifier. So VF is called feedback voltage. It is given to the positive terminal of the operational amplifier. So comparator provides the comparison output, that is X is the output of the comparator. So this is the successive approximation resistor SAR. So output of the comparator is given to the successive approximation resistor SAR. So the two basic operations are necessary for the SAR. So one is SOC, that is a start of conversion. So another one is end of conversion. So binary digits are, so we are taking the n-bit register means D1, D2, D3 and so on. Dn is the number of bits. So we are going to provide the clock signal for the register to generate the digital signal into analog signal. So D1 to Dn are the number of bits. So D1 is called most significant bit. Dn is called least significant bit. So output of the SAR is given to the n-bit DAC. So n-bit DAC converts digital signal into analog signal. And second, it gives the digital signal into analog signal. So we are taking the digital outputs from the SCR register. So the bit numbers are D1, D2, D3, and so on, Dn. So the function of comparator. So comparator used to compare the input voltage Vi and feedback signal from the n-bit DAC. So these two signals will be compared by the comparator. The output of the comparator is zeros or ones. That is, X is the output of the comparator. It is 0 or 1 depending upon the input value Vi and the feedback voltage Vf. So Vi and the Vf value decides the comparator output. It may be 0 or 1. For example, the comparator output is equal to 0 means Vi greater than Vf. So input voltage is greater than the feedback voltage means the comparator output voltage is equal to 0. So next, the input voltage is less than the feedback voltage, the comparator output is equal to 1. So X value zeros and ones. So based on the input voltage and feedback voltage. So this analog input signal Vi is given to the negative terminal. Feedback signal Vf is given to the positive terminal of the comparator. So output of comparator is zeros and ones. It is depends upon the input voltage and the feedback voltage. So next important part is successive approximation resistor. So it is a special type of resistor which completes the searching process for n-bit conversion in n clock periods. So it completes the searching process for n-bit conversion in n clock signals. We are going to provide the clock signals. So for example, bit number is n. We are considering n-bit CR means, so it consists of n output bits. So that is from D0, D1, D2 and so on, Dn. So this resistor, Dn is the most significant bit. So D0 is the least significant bit. So two basic conversion signals are available. One is a short of conversion SOC. So SOC signal is given as input to the SCR to start the conversion process. Once SOC signal is given to the SCR register, then only the conversion process will be started. So on the completion of the conversion process, so end of conversion ECO signal is given as output from the SCR. After conversion of the analog signal into digital signal, so SCR gives the end of conversion signal. So to enable the conversion process, the clock pulse is also given as input to the SCR. So according to the block diagram, so successive approximation register, so we are giving the converter output X and also giving the clock pulse. So two signal, one is start of conversion and one is end of conversion. So start of conversion signal should be given at the time of conversion process starts. After conversion, so end of conversion signal is given by the output of the SCR. So the clock pulse is very important. So during each clock pulse, the comparison and the approximation process take place. Therefore, the input signal given to the SCR. So three input signals are for the SCR. One is start of conversion SOC, another one is the clock input, third one is converter output. So operation of SCR. So initially, on giving the SOC signal, so MSC bit of SCR set to 1. Other bits are set to 0. For example, we are considering the 4-bit SCR means the initial value of the SCR is equal to 100. So first bit is equal to 1, and the remaining 3 bits are 0. So depending on the converter output X, which is given as the input to SCR, output bits of SCR are changed at the end of the conversion of each clock pulse. For example, if the converter output is 0, that is, so input voltage is greater than the feedback voltage means the value of the MSB is retained as 1. So VA is greater than VF means that is converter output 0, the values MSB is retained as 1. The next MSB bit is set to 1. So the new value of the output is equal to 1100. MSB retained, next bit also set to 1. So if converter output is 0. So otherwise, if the converter output is 1, that is VI less than VF, then the value of MSB is set to 0. And the next most significant bit is set to 1. So the EQ number becomes, so input is 100, initial state is 100. So if converter output is 1 unit, it is modified into 0100. So similar to this process, the output of the SCR is changed during each clock pulse, depending on the value of the converter output. So therefore, at the end of the nth clock pulse, the conversion or approximation is completed and EOC signal is given at the output. The output n bits of SCR is given in parallel to the digital to analog converter as an input. So SCR output is given to the DAC. So digital to analog converter. So in this, DAC, in this analog to digital converter method, so we need for the digital to analog conversion technique also. So digital to analog converter. So output of the SCR is converted into analog signal. That analog signal is given to the feedback for the converter. So we should convert the digital output of SCR into its equivalent analog signal. This analog signal is given as a feedback to the converter. So feedback signal is compared with the input signal by the converter. So advantages of successive approximation type ADC. So it consumes less time. There is a very low conversion time. So maintains high resolution. So resolution of the ADC is high, low cost compared to flash converter. So compared to flash converter, the cost of the converter is low. So it has some disadvantage also. The disadvantage of this type of ADC is it requires a complex successive approximation register. So SCR circuit is a complex. It requires digital to analog converter. So instead of ADC, we are using the digital to analog converter. It provides medium accuracy. So not provide the better accuracy, provide the medium accuracy. So finally, I am going to conclude this lecture. So just more recap. So successive approximation type ADC, this is one of the most familiar analog to digital conversion technique. So here we are using the special type of register, successive approximation register SCR. The important parts are the comparator, successive approximation resistor, and the DS. So analog input V is given to the negative terminal of the comparator. So output of the NBDAC is given to the feedback signal, the positive terminal of the converter. The converter provides the output X. So if input value is greater than 0 means output is equal to 0. So input is equal to less than VF means output is equal to 1. Based on the converter output, SCR generates the digital outputs. So we need to provide the clock signal to produce the digital output. So total 3 input signals are available for the successive approximation register. One is converter in output, another one is SOC, third one is clock pulse. So after conversion of the digital signal, so end of conversion signal is given by the SCR. So again, this converter digital signal is converted into analog signal for providing the feedback. So these are the advantages and the disadvantages. So advantages mean very low conversion time. So maintains high resolution, low cost compared to the flash converter. So disadvantage means it requires a complex resistive successive approximation register. It requires ADC, sorry, it requires a DSC. It provides a medium accuracy only. So not a maximum accuracy. Thank you.